I guess we can begin the class. Do you guys have any specific questions you want me to take? Feel free to ask. Um, Today we'll discuss something about basically the topics from week 2. So the lecture covers some of the topics like constant, inline, and such. So we will be covering those things. Now, if you want me to take anything specific, please feel free to ask, or else we can start. Okay, I guess we can start then. Uh, can somebody confirm my screen is visible? Great. Thank you. Okay, so as usual, we'll start by writing some programs. I'll describe how const itself works. So what is this const in C++? We'll start by writing some program. So like hash include. I'll be printing stuff. So we will include IOStream. Again, integer name. Then what I want to do is, as we saw before, we have like we printed hello world and such. Today I want to see what this variable const is, right? So what I can do is I can define some integer, let's say p, which is a value 7. Okay. Now I can print this guy. So I can do something like this value of p is p and end the line. Now this thing will print the value of p. So maybe we can test it out, right? But prints the value of p, which is 7, because that's what we input. Uh, what other way we can do is have a qualifier. It's called a const qualifier. What it basically means is my variable, which was I defined as p, and the data type is integer. That is fine. But what extra this information when I put const has is the value of p cannot be changed. Okay, so it is like constant. So what I can do is, yeah. So input terminal commands. You can just probably look up online. There are not many commands that you need to know for terminal. What I suggest is go with something like bash from Linux. This I'm using Mac, but a lot of these commands are similar to Linux also. So here I'm using some the shell is called ZSH, Z shell as you can see here. ZSH. Usually you'll find bash as the main terminal for Linux. Most of the commands are similar and across these shells. So you can probably just look up bash, basic bash commands. Maybe I can teach you guys some right now itself. Uh, so ls is a very basic command which prints out. It basically means list. It lists out in wherever you are in the current directory, all the files and such. Like it just lists them out. Then you can actually see. Yeah, so like you can do something like star dot cpp. So star is like a wildcard. So star basically means whatever be the characters in the file name, but ending should be .cpp. So if I do that, I just have one file, it will just make those. So currently you can see I have files like here and here both. Because of VS Code, you can see on the left side, it's const.cpp, and out is the executable file. So that also is visible here. Both of them are. Now, um, so ls does that. So let's say I have another file which will be inline.cpp. So if I do the same ls star.cpp, it just gives you const.cpp and inline.cpp. It doesn't list out. So you can filter the files in your current directory also through this method. You can also get the pwd command gives you the full name of the current directory. So it gives the full path, helpful for knowing which current directory you are in. So clears the command, the terminal. So ls this, and there are some very basic bash commands like um, uh, cut, uh, sed, awk, grep. Grep is pretty useful, so I'll show you guys grep. So it is useful in learning. So let's say I grep some line. I want to like search files, right? So let's say I want to search in const if there is a thing called uh, value, right? So I'll search for value in const.cpp. So it lists the line exact. It actually found it, and it highlights that line that it found grep inside line inside this file. So I gave some exact file, but I don't know. Let's say I want to grab the whole directory or something. I don't know the full the actual file name also. So what I can do is I can just wildcard this, and then it searches all files with const with not sorry const with files ending with .cpp. So here it shows that the const.cpp it found value, and because anyway inline is empty currently, so it doesn't find anything there. Further, you can give values like r. I mean, r is like recursive. So what I'm giving is n. It shows the line number also. N will give you the line number itself also. So line number 6 in constant CPP, as you can see here, has this line value. Has this line which contains the word or the characters which are need, which I wanted to find value. Yeah, that's so essentially, grep and ls and such commands will be mostly what people tend to use. It depends on your use case. What I suggest is to get familiar with these commands, just try practicing them. Maybe while writing these codes, you can probably integrate how you want to use this command. So that should give you good practice. Uh, yeah, probably. Oh yeah, thank you. Yeah, that's good. Welcome. Hope that clears things. Yeah. Other than that, mostly I'm using terminal to compile and show you guys the command. You can do it through VS Code, but I just prefer this way. So just doing this. Oh yeah, auto completion. That is something I have because of my shell itself, VSH. Uh, there is a you can have plugins and such. You can probably have same plugins in other bash and such also. You just have to install some plugins. Yeah, that clears things. You can, yes. So essentially, you can have any shell you want. Uh, and then when you have a terminal open, you can say which shell to, uh, what I say, which shell it will initiate actually. So you can use bash, you can use ZSH, you can use anything, up to you guys. But more or less, all most of them have pretty much similar commands. There are some things which ZSH does differently than bash and such, but most of the situations bash is fine. And there are other shells also like RC and all. But yeah, you can just use bash. You can have multiple shells inside in a single computer. Yes, you can have. You can install ZSH, try it out. But if you have bash, I honestly, not honestly, it's like for most cases, it's pretty much the same task. So you might as well just have use bash and then go with it. The only reason to uh, what I'm showcasing is like a plugin, right? So you can probably find similar plugins inside Bash and then install those and then have auto completion and such also. That's it. What scope resolution operator? Yeah, so scope is something essentially think of like you have this parenthesis, right? Anything within that is like a scope. Okay. You can have variables, you can have functions, you can have anything in C++. So the idea is that whenever you have a scope, after uh, the scope, let's say you initialize something. Uh, yeah, there's a question. Can I use Notepad++ for compiling? I'm in W, but use not ID. Is this? Yes, you can. So what you have to do there is instead of using VS Code like I'm doing now, you'll be using Notepad++ to write a program like this, right? But the next step will be using MinW to compile. Yes, absolutely, you can do that. So essentially, you can go to terminal, uh, just type G++ and then start compiling. Your MinW should be in the path. So your G++ should be in the path. And yeah, it should automatically take care of it, or just give the full path to G++, and then the command output like -o out, and then whatever the file name and such, and so on. That should be okay. Yes. MinW. MinW is usually yes. You're welcome. MinW is usually for Windows systems. Yeah, and you can absolutely use it. Yeah. Okay, like I was saying, scope, right? So let's take this example itself. So I have some parentheses. I define my const p here, and then have some standard cout function, and then its end. So what happens is within parentheses, the lifetime of any variable, any function exists. There's a question. Operation summary help in terms of the prefix. So we require to use them. Yeah. So actually, yeah. So it's all about you are right. You're heading the right direction, Anuj. So thing is with scope, the main idea behind is that my variables will only have lifetime under within that scope. What I mean by that. So let's say I have a scope where I just take this. Yeah. So what happens is here is I can just have brackets open and close. I can do that. I have this bracket open and close for the main function, which is like the superset you can think of. And for uh, this variable itself, I just have some dummy like just closed within parentheses. Now, thing is, what do you guys think will happen to this program? Remember, for variables, if I have within parentheses, the lifetime or the scope of it is within that range. Okay. Now, so let's say I have this variable p. I've defined it const integer p equals to 7 or something, but I've put it inside parentheses. Okay. Let's see. Let's compile this program and then see what happens. Yeah. As expected, we should get an error. Can anybody tell why is this an error? I mean, there's a the compiler itself throws a warning message. Uh, yeah. So the ID that there's a question. So the ID I'm using is VS Code. Maybe I can show. Is it written somewhere? Oh, no, but you can just Google online and download this program. It's called VS Code. It is available in all major platforms: Mac, iOS, Linux, even Android also. Yes. Not the scope of cout. Yeah, you can think yes, not the scope of cout. So
Sir,
yeah, fine. Yeah.
sir, I have downloaded the Visual Studio, but
Mhm.
it is not showing me, means it is showing me C, C++ extension installation. So do
So
I need
yeah,
to install extension pack?
yes. So it's not like necessary. What extension
Okay.
helps you to do is it helps in code filling and then some color and all, like for those kind
Okay.
of things. Yeah. So
Okay.
for it is. it enhances your writing of code, like helpful in that sense. So like let's say I get this thing, right? So there is you can get some quick fixes and all. So for things like this, it is helpful, but you still need to install some kind of compiler in your system if it is not there. Yeah. So GCC
Uh,
is like very standard. Yeah. Sorry. Yeah.
okay,
Please go
that
ahead.
means I have
Yeah.
to externally install the GCC compiler, right?
Yes, that's correct. Yeah. So what
Oh,
platform are you using? So if you're using Windows, Min, GW, Cguin, these are quite common. With Cguin,
okay.
you can just get the G++ executable itself, and you can and add Cguin to it. The path is something like think of it is a list of directories which is available to anywhere. So let's say you are in some current directory. So let's say I'm at this current directory. PWD shows me I'm at this directory. Usually you just have access to files here. Like whatever do I do ls. So here I can have access to files here. I can do cd dot dot like I can give the full path to anywhere. That's okay. But uh, to not always give full path every time, we add certain directories to something called a path. Path is like an environment variable. So it's like PATH in capitals. We can actually do some echo dollar path. I am not sure if I can show you here. This. Maybe it does exist. Okay, yeah, Mac has it also. So yeah, I'll come to the questions. Sorry. So let me just complete this. So echo path shows me the all the directories that are there in my path. So you can see the underlying thing. The so opt then local bin, then uh, colon, right? So there's a separator. So this is one path. This line, this folder is in also in the path, and then this folder and this folder, and so on. So there will be certain folders or directories always in the path. So what Cguin or NW will do is add your installation of G++ also in that path. So you can access G++ anywhere, essentially.
Sig
Sorry.
Sigwin, right?
Yeah, I can probably just write it's CYGY, Sigwin, and
Okay,
yeah, it's in
okay.
MSVC. And then you have also Ming and GW.
For to download that or install that, how I can means I have to search. Where should I search that?
Just
On the
Google,
Google or
yeah, Google is fine. Yeah. Just Google
with
Sigwin
how?
installation.
Okay, okay.
Yeah, just Google Sigwin or MNW and then install. You can probably like go with either. Sigwin is what I've mostly used, so I guess you guys will find that more comfortable to use. Try either. Both are equivalent, I would say. Yeah. Now, yeah, let's come to the questions. Yes. Yeah, as we were discussing about, yeah, P is not defined. Yes, it's not defined. Is correct. That's correct, Aditya. P is not defined in the scope of the out. So, uh, what happens here is because of these parentheses, I have variable P inside, right? So it gets initialized. And then as soon as, always remember, as soon as the parenthesis hits, so or any variable, even any function also, it goes out of scope. Like it is not in this scope of this like empty. So it is some parenthesis. It's destructor it gets called. You'll learn about constructor and destructor. We will cover that later. So essentially, think of it like it gets destroyed. This variable no longer exists, and essentially, it's like you can just ignore this, like comment them or something. This program is essentially like how this behaves. Yeah, for the subsequent lines. Of course, you have this code. I'm not denying. You have this code which functions, but for this function, it might as well be this whole thing is just commented. Yeah. So is defined in the brackets. That's correct. But I hope that is clear. It is defined, but not for this guy. It because it's destructed is gets called. You can't for standard cout to access P here. It doesn't know anything. It just got destroyed also. So too bad. Abhishek, it's not mandatory. You guys can join if you have questions or not. his lectures and record PA sessions, live sessions will be recorded. So you guys will probably get links to that also. So it's up to you guys if you want to join this or not. Uh, but again, this session held because you if you have questions, you can ask, and then I can clear some doubts. And again, probably some of these live sessions so that questions are like the things get clear. That's the main idea. Yes, Advait, yeah, that's correct. You have to uh, uh, put the Ming GW64. So 32 and 64 are like what kind of systems you're using. You can probably just go with 64 because if you want to use the program as 64-bit uh, system, because usually we all have 64-bit systems. So probably go with those. Yeah, okay, there's another question. Sometimes when I run code, it prints errors, but then I check the code on an online compiler and it works. Why does it happen? Yes. So what you have to understand is like we also saw that last time. What happens is compilers are different. They behave differently. So you can have GCC. You have so many compilers. You have GCC. You have Clang. Clang is something that I'm currently right now using because of Mac. This does the inbuilt compiler. Then you have MSVC by Microsoft. You have Intel compilers, ICPX. So each of these compilers are written to compile your code, yes, and they do follow standards like standard C11, C++11, 17, so on. But you do have 11, 14, 17 plus 3 years, so it's like 20, 23 and all. But you do have to understand that the way they follow the standard and need not be the same. So they have all these compilers have their own way of optimizing stuff, and because of that, they will have certain kind of things will throw error and certain kinds will not. So some compilers are uh, will not throw you warnings. You can suppress warnings also, because let's say you do some things which are not exactly errors, but they're more of like warnings. You can suppress warnings by giving flags, but other compilers will by default suppress warnings. Some compilers will by default have all kind of warnings on. So it depends on the compiler you're using. And yeah, that's more or less it. Yeah, thanks, Ajay. That's correct. Yeah. So you guys can follow the chat for more instructions on how to set up Ming W64. Yeah, he was defined outside main. Yes, that's a very good question. Yeah. So again, that's also a scope of the program. We can actually also define P outside the main. It's actually also absolutely valid. This is completely valid. You can actually think of like your whole program has a scope of starts with a like this angle, this parenthesis and ends there. You can think that way. Yes, that's absolutely correct. Absolutely fine. And let's say I do define const to be like this, and then just to realign stuff, I can have empty parentheses. It's okay, absolutely okay. Yeah, I can just have something and end here. Define my p here, and then access it inside main. Let's see how it looks. Yeah, that's absolutely okay. So yeah, P does have access to this call here, has access to this defined P here because it's outside, it's still inside the scope. You can have variables within parentheses which are later defined access variables outside. That is perfectly fine. But just remember, if something is defined and then gets closed, it just gets destroyed. That's the main thing you should remember. If it gets destroyed, nobody has access. So that's the main idea behind scope. Uh, so lead code, yeah, I mean, you can solve in, I guess, any programming language. And I guess there are questions depending on programming language. Uh, but lead code, you can definitely go for resources like lead code and such. where you get all kinds of levels of questions, right? If you're starting out, I would suggest go with the beginners levels and then maybe go to advanced stuff. Yeah. But to understand these concepts, you can probably find other resources also. I'm just saying ki you should not restrict to just one kind of resource. Sure. There's a question. Okay, let's type that out. Let me write the question. I do need to see out, so I'll include the. There's a question in the chat. Int x, and then I start my main function. Okay. Inside main, I'll have int x equals to 10. Okay. And then standard cout to global is something. Put I don't fully understand your colon x, but maybe there's a namespace there. So there will be another one which is like local x is this. Okay. So you can technically have this outside here, right? And then inside main call this local x value of. Now thing is here x is defined. Okay. But do remember we don't set the value of x. So it might depending on the compiler. Actually, here this is a good example. It depends on a compiler. It will initialize this value of x to some uh, garbage, like have it just prints whatever it has here, or it sets to 0, which is the default. Again, that depends on a compiler. So here, if you print the global value of x, you may get x 0 or some garbage. But what you do here is you're defining x as 10, right? And then you're printing it. Now, thing is, do remember here you have a x which is global. I see what you mean. Okay. So do remember here you're redefining x. While the name of the variable you're giving the same, okay? You have a variable here which is defined out of like outside main. Okay, so x is global. Fine. But you also have x which you define and declared also as storing the value 10. This becomes a local variable. Okay. So while the name of the variable is x in both, they're actually two different variables. Okay. So what happens is, let's say you don't define this variable and set x equals to 10. Then what? Here x is global because you're not redefining in the variable. If you redefine with the same name also, it becomes a local variable. Okay. But what I'm doing here is I'm defining x, setting it to 10, and then because here inside main, I have access to this, setting it to 10 and then printing it. Okay. So yeah, here if I put integer, then this is actually a local variable. You can think of it like um, this is actually a different variable itself. It's called x, but for this local scope itself, you can have variables which are already defined, use the same name to define some different variables and work with them. Hope this clears things. Maybe I can just print and show also. Yeah, sorry, I should print the other file. and then I have dots out. Right. Let's see. Maybe let's go with this one. Okay. There is a page and we can- I see. The issue here is that we can't call standard functions outside main. Yeah. We can only call them inside some function. We can declare variables, but not call this standard share function, standard CR function. That's okay. So the local value of local variable is 10. Okay, that is fine. So, but let's say I didn't have this, then what? I've defined my value x here, which I can access because it is global for this function standard cout x. Then, uh, as I said before, it depends on the compiler. Here, my compiler set the value of to the default value, which is x for x, which is 0. So hence, I'm getting the value of x as 0. But do remember here, here what I'm printing, I might say it local, but here what I'm accessing is actually the global value because I have not defined x anywhere. It's just defined here and I'm using it. It's actually not local, it's actually global. Now, this is done, but what about now? So when I printed the value originally, it printed global as 0, okay, because it accessed the global value. Now let's say I define x, right, and then print this value of x. Let's just we'll know about if it is global or local accordingly, right? What do you guys think will happen? Yeah, it should print 10 because what I just did was I defined x and just printed it. It really doesn't matter if x here is defined as something. So we can actually do that also. Yes, it comes in value. If you don't assign a value, you're right. Yes, yes, yeah. That's yeah. It depends. It depends on the compiler. So it depends on the compiler. Sometimes it depends on the compiler version also. So maybe some compilers in some older version and older standards of like let's say C++ version of Clang, let's say, didn't have this feature to reinitialize. MingW's, let's say that's GCC. GCC's latest one will do this always. It depends on the compiler. Yeah. So certain behaviors like this tend to change, and yeah, you just have to be careful. And honestly, uh, relying on features like stuff like let's not call it feature. It's like stuff like this is not good practice because let's say you want your variables to be defined as 0, so you should actually just define it at 0. That's what. So if you define variables and then access them and print them or something, thinking that maybe by default the behavior would be 0, it's actually not a good practice because that actually leads to errors. You might have garbage values there and such, and then you don't know where the bug is, and then that's a whole other issue. Now, yeah,
Sir,
yeah, go ahead.
sir, if I wanted to use both the global and local variable in the main program, means
Right.
main, then how I can access the global variable?
Yeah, so as mentioned in the comment, you can use something like can do some this to access the so colon will access the global variable and just x because x is here, so it knows to access. So this x here accessed will be local.
Okay.
So let's see some more examples. Now I have defined my global variable, defined my global variable x as 0. Sorry. x as 0, and I'm defining my local variable as 10. So let's say I print x. What do you guys think will happen? Yes, that's correct. It should be 10 and it is local, right? So even if I've defined a variable which is outside, I'm creating a new variable and access it. Okay, great. So, but let's say I do this. I don't define the variable, but set it to 10. Can I do this? Yes, I can. Because what happens here is it all it in the scope here the x is global. Yes, it is declared. Yes, it is also initialized. Absolutely okay. But what I'm doing is I'm accessing that same variable again and setting it to 10, okay, and then printing it. That's also absolutely perfectly allowed. Here the x variable that is just printed is actually global. Okay, but if I declare it, right, and then set it to some value and then print it, here the x is local. I hope this clears the difference between global and local. Here again, the idea of scope comes in. So because in your program, whichever is defined, let's say before main or something, those variables are like in a global scope. You can think that way. And whichever is inside parenthesis here, like let's say main function, that is yeah, let's do that. Yes, that's it. In the chat there is a question. Let's do that. So I'll just complete this. So essentially, variables declared outside main are in global scope, and anything inside parentheses are local scope. Here, naturally, a function has parentheses, right? That itself also is a scope. You can think of that way. Yes, you can have your own empty, like I showed before. You can have your own empty parentheses also. So that's itself also is a scope. Here it doesn't change the program, but this is also perfectly valid. Yeah. So there is a question in the chat, and then let's okay. Uh, week one assignment questions. I'm not entirely sure if I can solve assignment questions. Okay. Maybe you can probably post the question in the forum. I'm not entirely sure if I'm allowed to solve these questions. Yeah. If possible, I can probably discuss some doubts or something. But yeah, right. Let's print the global variable x also. So I'll define it as local x. Okay. And then I have something like global x. Here I'll access the global x. Here I've defined local x. This is okay. The global x is defined as 0. Local x work. Yeah, great. So accessing the global x through the namespace colon. So there's no namespace as such. So there is nothing here. But ideally, like you can think of namespace here, like we have standard namespace, right? Because this is under some namespace, defined namespace. Hence we are defining and then putting colon colon as a name under which the function cout is defined. Here, the idea is same. So you access functions, you access variables, you access anything. You can access them through a namespace. Okay. Now there is the name. There's nothing named here. So there is just empty global function. So there is no namespace, but you can access those variable x. Now, interestingly, the global x is accessed. Yeah, access to C++. Okay, yeah, that's sure. Actually, I can probably show you guys again. I mean, okay. That has a question about the forum. I'll send it. Hopefully, you guys can access this. So yeah, NOC 24CS 125 should be the group. So yeah, if you have any questions, you can probably just post it there, and then uh, other TAs and such also could take a look at. So there is another question. You're welcome. Okay, okay, I'll finish something I want to say and then get back to your question. So let's say I have colon x, right? So here I know this is global, and here in the second line I have access to local variable. The question. Uh, so, but let's say I do not define my x again, right? I just set the value to 10 again. So what do you guys think will happen? Yep, both are 10. So like I said, here essentially what is happening is I'm accessing the global variable explicitly here. And here also, in a way, I'm actually accessing the same x variable, which is also global, right? So both of them are printing 10. Okay, storage area difference. Depends. So, okay, here I should uh, make something clear. There's a question in the chat about difference in storage area between global and local variables. So do remember, storage area is completely different than scope. Scope defines a local or global variable. Okay, scope here. So let's take an example. So here, x is integer, right? So these are like stack allocated. So that's like you can think of your storage. This is stack allocated because it's just integer, a single variable. These will be stack allocated. If I so we saw last week, right? So if I define standard vectors, you must have seen about malloc or things like that in C or new in C++, new keyword, whichever uses new and delete on some. If you use new and delete on something, that's like those are heap allocated. Okay, heap allocated means it is allocated on your RAM. Okay. Now that has more memory and that storage is different. Okay. Stack allocated is usually like it's cached and it always stays in CPU cache or something. Now here I have defined a variable which is stack allocated, but has global scope. Here uh, I'm accessing the same value in a different scope, like inside this scope, but since it has global access, I can access it, but it still is stack allocated. Okay. Here if I define integer, here I'm defining a local variable which is stack allocated, but is in the scope of the main. Okay. Let's say I define standard vector. It is actually template. So would be, let's say, integer. Why not? In like A. And define it to contain, let's say, 5 elements. Now, what happens here is I'm defining a variable A, which is in the local scope of main, but this is heap allocated. Okay. You can have uh, vice versa also. You can actually define like variables like this with like put in a header file and such. They will be in the global scope, but also heap allocated. So this is a very important concept to know that storage allocation is completely different than scope. Okay. So I hope that clears the question. So it really depends on how you define something. That will say if it is already exists. Yeah. So like there's another question accessing global variable. So like we did it here because it's in a different namespace because like you can just do colon and access the global variable. Ideally, what people do is they give namespaces. So again, namespace is also a scope thing. So standard vector has a standard namespace has a vector. So I'm accessing that variable, the function through this, giving the template, like defining that this vector will have contain integers and then giving size. Okay. Now to define uh, another namespace, I can just And this is- Just give some names. Let me call it local and then define stuff. Okay. So what this will do is I'm defined a local name. Okay. And then inside that I'll define X. So I have to define the type also. So int X equals to, let's say 5. Now here I defined namespace guy local. Okay. To access this guy, I can just do like something like this. And then maybe print it or do whatever. You can make your own namespace and then access variables later. Usually these uh, namespaces are defined in other functions also. Here we are usually dealing with main, so you won't see the much use of this kind of stuff. But yeah, the hope the concept is clear. Hope the main idea behind this is clear. Okay. Maybe let's can we have this a question? Can you have two different namespace and in different files? Yes, you can. So names, think of it like let's say you have different files, but then you have to understand: are you combining these files to a single executable? There should not be a collision. Like we discussed, I have a namespace standard inside which I've defined a function called cout. You can have your own namespace, let's say custom or something. I can define custom and have a custom. I have a definition for cout. Then absolutely do that. And and accordingly, your program will decide which cout to use. Is it the standard cout? Is it the cout under namespace standard, or is it the cout under namespace custom or something? There's another question. Which variables are stored in heap and which variables are in stack? Yeah, that's a good question. So usually think of it like this: all the arrays, so defined like so C style arrays, right? So int array A equals to, let's say, this uh, 5, 4, 5, 6, something, whatever. So this is a C style array. Arrays are generally stack allocated. Okay. This single variables with just uh, define like integer. So these things, double, single, float, integer of like a collection of arrays, C style arrays. Uh, these are stack allocated. I also showed you guys standard, there's a vector, so standard array. This is also stack allocated. You have to give the size and uh, yeah, you don't give. Yeah. Yeah, you can give the values also here, but anyway, so this is also stack allocated. The only things which are heap allocated will have are variables which are defined like with new keyword, malloc, so and so on. So new is from C++, malloc is from C. These say, maybe I can show an example. Give me a second. There we go. Yeah, you can look up online, but maybe I can just show. Maybe. I was going to show you new first. Maybe you can do malloc. you can do something like this. Okay, so that is also you can do. Let's declare and C++. Okay. Let's do the malloc and new, and then maybe use those tools. So let's do something like, okay, I'll have an integer pointer. Let's say a. So maybe I'll do it here. As another thing I can probably show you guys is to declare new file, like create new files. You can do touch and then keep the file name. So maybe we can do this as keep. So the file is created. Use that and do iostream. As usual, int main. Now the idea is to declare variables as array, like stack allocation or heap allocation. Right? Do this. So, yeah. So integer x equals to, let's say, 10, and then can define another integer, but this time, so this x was stack allocated. I'll do something called heap allocation, but so it had to be pointers. So the reason in C at least, the reason we do it this way is think of it like this. Stack, we know the value, we know what's the size of it. It's like because it's small and such, we already know the predefined size. But in heap, what happens is you can have variable sizes, as in compile time. If the sizes are known, you can, I mean, depending on how big the array is, you can put it in your stack. Okay, because there's a limit on stack. You can't have very large number of values in that. So stack enforces to have know the size of the variable. So because I know my x is an integer, how much it will take integer size. So let's say it 4 bytes or something. So it will just allocate the data and assign 10. Okay. But for my heap allocation, because because it depends on the program. So sometimes I want variable sizes. So let's say so for example here, actually, so let's say this standard vector, right? It has 5 elements. I have defined it. I can choose not to define this and then just go ahead. I'll show that also. So maybe let's do it the C++ way first. Things will be clearer a bit. I'll define standard vector. Okay. Then I'll make sure that all of them are integers. I'll just define it. Okay. So there is a we print the size of it. The nice thing about using this uh, class defined, already predefined class is that it helps me know a lot of the values and such. It's because it's member of the class. So because, let me just do this. So a size, or maybe right size of it. Now there is a function inbuilt to it, which is defined for vectors, which is size, which I can access. It's basically a function. What this does is it tells me the size of a. Okay, because I'm not defined anything here, I expect it to give me 0. Let's compile and run this program. And, yes, again, I have to include the name vector 2. Again, So the idea is clear here because I've defined my vector A, but I did not give it any size. So hence the size of A is 0. But let's say I resize it. There's a method which says resize it to 5, and then print the same value. Remember, A here is heap allocated. Okay, right? Because it is heap allocated, I can resize it as I wish. I can have very large values depending on the size of my RAM allowed, but I can have very large values, and I, the size of it I can dynamically define. Hence, these are dynamically allocated. Okay, so its size is 5, and let's loop through it also. Like there was a question. So the most common way of looping is going variable by variable. So let's do that. This is what normal people do. So I can just, I did not know the size of the A because size variable will always keep track of it. I can put 5 here or 0 or anything, but I can just put, to print the whole A, I can just put the size of it. Then put plus plus and then print. So something like, improve it, 5, the value of A. So here I'm accessing the ith value of A and then printing it. Okay. So for 0, so because there are 5 values, it prints till 0 to 4. So the way C++ works is your indexing starts with 0. So be careful with that. The indexing starts with 0. And let's say your size of A is 5. The n minus 1 value will loop through. So it will go through till 4, print all those values. Now, because of compiler and also in general, what happens is because this is a class, right? And when it gets initialized or anything, so here because I did resize, there is a thing called default value. So hence it just filled them with 0. This is a common behavior. So hence we got values as 0. Other thing I can do is I can actually put something inside. So like actually we did this last time. So put something, I'll fill the vector and then again print it. So this time it will print the ith value. Let's just store it, right? So it prints 0, 1, 2, 3, 4. Can actually do something like plus 1 or 2 times, or maybe give it times 3. So yeah, so this gives the expected value. Okay. Now coming back to heap and array, right? So this is some methods I did for allocated heap. So C++ makes things very easy. Let's see how we do the same in C style or using new and malloc. So what you do is rename this. So we want to define that. So remember, as we saw here before, I can have variable sizes, right? But what happens is the starting point I should always know. Okay. So let's say I have a huge block of array, right? I have a lot of values. I have 5 values there. I have 100 values or something. They are stored together, so one after the other. It's called a contiguous data. Okay. This is a term to say all the values, all the numbers here are stored together, like continuously. Now, to access each value, I actually need to know the starting address, right? That's what we do. So we store the first pointer to it, okay, let's say A, and then I'll define new to actually allocate the memory. So I'll define, let's say, we compile. Now, what I'm doing here is I'm using new keyword. Keyword is like, think of like, it's kind of like a function, but not exactly. This function have their own grouping. So here I'm using new to declare uh, 5 integers, but these are heap allocated. So remember, whenever you see malloc or new, those are heap allocated. And again, whatever I did here, which as you can see, it's much cleaner also. So you just define standard vectors and then resize and keep working with them. Same thing you have to define through something like this. So pointer A now has 5 values. Like it has capacity to store 5 values. Now we'll store them. How to do that? I can just use the bracket operator. Here, since I don't have any method class to do a dot size because this is not standard vector, I have to put the value the 5 and equals to, let's say, 2 times. Okay. Same thing as expect. So you can do the same thing using the keyword also. But yeah, it's like you have to also, here there is a something you have to also remember to delete this because you have allocated something in stack. You should not forget to delete it. So you have to do delete A. Otherwise, you might run into some weird issues. So, but the nice thing about C++ is that it automatically takes care of. So, like I said before, here I initialized A, right? So, which is inside this scope. Okay. Now it gets initialized, but as soon as this parenthesis hits, the destructor of this A gets called. It automatically gets deleted. So memory managing through new and delete is automatically taken care of if you use standard vector and such. Yes, there's a question. Please go ahead. Yes, Priya, you have a question? Yeah, not using standard vectors, but probably through. So what people do is that you can define them, but ideally the idea is that okay, uh, it should be clear here also. So the variable pointer, right? A is a pointer. You can actually define the pointer globally because that will be stack allocated. What I mean by that is the variable A which stores the address is stack allocated. It just needs to store the address, right? That's a very small value. It will just store it in the stack. But the address that A is pointing to, that is heap allocated. That address exists in the heap. or the RAM or whatever it is. Okay. Yeah, actually, we can actually do that also. So let's define integer pointer uh, pointer A. Okay, and I don't know if this declaration will work. Let's see. Might throw error. Okay, it worked. So what I did here is uh, clarity. Yeah. So what I did here is I declared A in global scope. Then I defined A to have like dynamically allocated memory inside main, and then just stored and printed, and then deleted it. That's okay. What you should remember here is this variable integer pointer A. Oh, you don't have to worry about attendance. Teams will automatically always take it, so don't have to worry. Yeah. Anyway, I plan to not take any attendance, so that's up to you guys. Yeah. I did say last time, I guess I'll take attendance, but apparently that's not required, so it's okay. You guys can attend these live sessions as you, if you have questions, if you want to ask doubts here and clarify some questions, concepts. Yeah. Attending this will be up to you guys. Yeah. Right. So yeah, like I said, these sessions will be recorded, so you can uh, see them later also. So that's so yeah. Feel free to leave if you guys uh, want to. So that's okay. So here what I did is declare integer pointer a. So a is a variable, sure, but it's also what I'm just saying is it's a pointer of data type integer. So what it will do is it will store an address, right? But the address it is storing to, those values will be of integer types. So uh, it will know how to parse it. So let's say it starts with some address. After 4 bytes, it will know the next variable. And so this variable can be stored inside because it's a global scope and integer pointer. This is stack allocated. The variable a itself, if I strictly speaking, is stack allocated because it just stores an address. But the address that it stores, right? Address it is pointing to, that is heap allocated. So these variables 3i and all, they are on the memory which is heap allocated. Okay, I hope that clears the question. So maybe there was one last. There was a 2D question. Wait, let's do that too. Let's actually do. So here I'll just use C-style array because 2D arrays. You can actually use vectors to do. Maybe let's do both of them. I'll do this integer a define 5. So here I've defined array A, okay, of size 5 by 3. You can define like integer wait, after only integer B as 7. It's a 1D array of size 7. Here it's a 2D array of size 5 cross 3. So 15 values it will store. So you can have integer type something like array C, which is let's say 2, 7. It's a 3D array. You can have ND arrays. That's absolutely okay. But again, do remember these sizes are known, need to be known at uh, compile time, right? Also, the important thing is this is stack allocated. So you cannot give very large values here. For those things, you actually heap allocate stuff and then work with that memory because otherwise it will just throw stack overflow. So you can do any declare any such thing. So it could be 2D array 1D array, 3D array, and so on. Now, to access these values, so for ND array, you have to write n for loops, essentially. So what I'll do is I'll write n uh, first the first variable by I, second by j, and so on. So we can just do a, second size is 3. This values, I'll just store them. Let's say again a, a plus 5, let's do it. I'll print this guys. I'll use the same two loops and then just print these values. To value a, and then access them by corresponding indices. Let's run this program. Okay. Yeah. Yeah. I did not print the uh, indices, but as you can see, I filled them with some values, and then it started just printing stuff, right? So this is uh, a way you can fill the values, access 2D arrays. So you declare them, you can just fill them using some, you access them by using n loops. So let's say it's an ND array. Here I accessed a 2D array, filled it with values, and then output is the same. You just use the two loops to access both the values. Now let's see, can we do the same in how to do the same in, let's say, C++, right? So here these are stack allocated, but let's just imagine for a second you want to do the same for heap allocated arrays, but in C++. Okay, so let's do that. So standard vectors. This time I'll not forget to include the vector. So standard vector for integers. Will not define a because that will hash. So it will be then I store it as 15. So remember, while this is a 2D array, the last values, so the it's like okay, think of it like there's a convention in C and C++. You have values. Your storage goes from like first the rightmost and then so on to the left. So these three values, whatever they're representing, they are stored first and then the five values, like strided by the. Okay, what do I mean by that? Maybe it's pretty clear. So essentially, think of it like you're still storing 5 cross 3, 15 values, right? So essentially, at the end of the day, it stores 15 values, not in a grid, but in a linear line. Because all the storage that happens in computers really happens in like a linear line. Okay. So doing this, A as 5 cross 3, and doing this are equivalent. Okay. This is stack allocament, this is heap allocament, but for getting the allocation of storage, where it is actually allocated, the allocation itself, the idea, main idea is the same. Okay. So what I'm doing here is storing, like asking vector to allow me to store 15 values for D, and then I'll work with this. So let's go ahead. So what I'll do is integer I equals to 0, I less than 15, because I already know the size, so I just put 15, I plus plus. Then access each guy. But here I'll just store this starts with 5 and then moves to yes, it stores from 0 to 15, right? So I can just do this. Actually, it stores the variable so that it will actually do that. But it stores each value to its best index, right? Okay, great. I'll do another print. But instead of A, I'll be printing D. It's essentially the same. So I stored just A from 0 to like its size n minus 1. And similarly for D. Okay. Now, here what I did was combine the 2D array into a single linear array. And essentially, this is what happens in uh, computers also, like in general. You can also do it wait, like I rethought the same 2D array as a single array. Okay, I can also do this. I can have, because vectors are templatized, you can make a standard vector of standard vector. Okay. Right. Now, second thing you can do is A, resize A as the outermost first, because think of it like the standard vector is an array, and of that array, you're making more vectors. So you can actually just make first resize the first one to 5, okay, because this is the outermost of the loop, and then each of this array, okay, we will resize to 3. So 0, A dot size, okay. Now each A, okay, A of I. Now remember here, okay, I should not call it A, make a new variable E. So remember, E is a standard vector of standard vectors. So you can actually access each of I, but remember this E of I after access is also a standard vector. What I can do is resize them to 3. Then then now I'll access each value. Here I can use this double bracket operator. So I'll have two loops. Then I equals to 0, I less than I'll give the actual numbers then. 5, and then I plus plus. Same loop, but with J, different sizes. Yeah, 3, J plus plus. Now I'll fill these values. So A will access, sorry, E I'll access as. So this will access the first level of vectors, and then each vector I'm accessing its jth value. Do that and give it the same J plus. And print this guys. but with this little formatting. Okay, and escape. This standard vector needs to be templatized, and this standard vector I'm templatizing by this template, which I'm saying will be a vector of integers. Okay, maybe this error. Let's not worry about that. I hope the idea is clear. So you can actually do the same 2D arrays by just doing C style. You can, like you saw, you can do using heap allocation here, using new keyword. You can actually look up how to do malloc also. Maybe I can show that also. But essentially, that is the idea is same. So you use these keywords to define a block of memory. Then, as a good practice, you should.
Sir, you are not audible.
Oh, sorry. Am I audible now?
Yes, sir.
Sorry about that. Now, okay. I hope I did not. So, why did you guys lose me? So here I explained about the heap and stack, right? The 2D array. I hope this is clear. Uh, Here I'm trying to define. I'm explaining macros. Okay. So here I'm defining something called hash define p as 7. You can do const integer p as 7, but there's a big difference between these two. So what this is, what this hash define is a macro, the preprocessor. So when your program gets compiled, right, then what this preprocessor or hash define does is before even generating the assembly code for this, right, it will convert these functions and variables to machine instruction, like first assembly and then machine instructions. Before even doing that, we'll just read through the whole code. Wherever it sees P, it will just replace that. Okay. Now let's see how that works. So I did not define P as a variable, but I did a macro. So what essentially happens here is P is not actually a variable. It doesn't exist in a way. So what this hash define does is wherever it sees the letter P itself, okay, it will just replace. Let's see how that works. So, so the value P was replaced with 7. Okay. So this is a way which C introduced. These are called macros. And this is how also people write a lot of code. But there's a quite danger to it. And you should be very careful while using this because the small letter P can occur in many places, right? So it can be some variable or something. So usually it is not a good practice to define your variables using hash define and such. So people write capital letters and then let's say some max and then give underscores and such to actually say no, this will not, this variable, this thing will never be used and such. So be very careful while using hash defines. So this is a preprocessor, this is a macro, and this actually is completely different than something which is like which is defined by P. So here I'm saying here it is const. So if you have a question, then you can ask or else I'll mute it. Type diff. There's a question. What does type diff do? Can do as same function as hash define. So again, type diff is I wouldn't say it's like similar, but the reason to use type diff is to even if so let's say I don't have a data type defined, I can define data types as something to to declare that this my new data type will be defined as some data type. I use type diff. So that is there's a distinction actually. They are not the same thing. Hash defines are macros. Type diffs are again keywords. I hope that answers. Right. So here, like I was saying, so hash define is a preprocessor macro. Uh, you can define P or some variables and such. Uh, but to understand the difference, the variable that you define is actually it doesn't exist. It's never actually stack allocated. What hash define does is if you define P, it will go through the whole code, replace wherever you see P as this value 7 or something. Let's say I define P here. And that's it. Then it will start compiling the code. It happens even before the compilation of the code. But let's say I have const integer P, there will be like P is a variable, it will get stack allocated, it will be stored 7 and all that. The usual thing that we know. So do know that there's a big difference between these two. And okay, now this saw like in this question, here I had an integer x and there was this global scope and local scope whole thing, right? What does const do? Right? What const does is it says that this variable p cannot be changed. Once I define this const integer p as 7, I cannot change it later. So for example, I try to in this local scope, I try to change p as 6. This should corner as it actually should because I actually defined it as const. I should not be allowed to change it again. Right. Now, yeah, I hope this concept is also clear. Now, what people do is they also use something called inline. Okay. Now, maybe I can do this. Okay, let's get more question, like more take more examples on this. So what I'll do is I've defined const integer p, right, as 7. That's good. Now what I'll do is I'll define some other variable. Let's say integer m equals to, like, this is fine because this is a local variable. I can do that. Now what I'll do is I'll declare a pointer, which will be something like this. So integer pointer p, not p, sorry, what is it? So here n is a pointer, and the value it stores is 0. What I other thing I can do is I can give the address which is pointing to n. So let's say n equals to the address of invalid code. So let's just remove that. Maybe let's just go. Yes. So there's a question in the chat. Difference between a pointer and a reference. So think of it this way. Reference is also something like okay. Usually the idea behind a reference and a pointer comes when you're passing to a function. Usually. Maybe can cover that also. So I'll maybe briefly describe what the main idea is. So let's say I pass a pointer to a function. That function has access to those values whichever the pointer is pointing to, right? I can also pass by reference. What it essentially means is I'm actually passing the same variable. So in terms of reference, okay, maybe I'll show an example later. Maybe that will clear. I'll come to the question. With the example, probably it will be more clear. Let me just finish this. So there is integer n 5, okay, and then pointer n, which I'm putting as 0, and I'm giving the address of m now. Okay, now I'll try to print what is n. So to print n, I have to dereference the value. So it prints 5 because what I'm doing here is I've declared integer n as 5, right? Initially I just stored the guy it is pointing to. So n is pointing to something. I'm storing there 0. But again, I redefine what it points to. It points to m now. So hence it prints 5. Now, uh, here I have a variable which is p. So can I do this step? Give an error. Now, here's something you have to also remember. Similar to how you have variables which you define as const, normal variables, pointers also can have const reference, const qualifier to it. So what that means is your variable is integer p and it's constant. Okay, I have declared a variable. I've declared a pointer n of integer data type and storing some value. I did not define it as a const integer, const data type. So what it means is I have defined n which, which stores an address to some values which can be changed. Yeah. By this declaration, it actually means that. So I was able to give the address of n, which is again without const qualified. Okay. So I was able to give it. But if I try to give a variable which is const qualified, let's say p, I cannot do that because p cannot be changed. And I've defined n, which is not const qualified. It says that I can change, but then I won't be able to change because p is const qualified, right? So hence the error. Maybe I can do the difference between reference and pointer. this concept is clear, let's take another example. Yes, so there's a question in the chat between standard vector and standard array. I actually covered this last week, but you can find the code also, but briefly I will just describe again. So standard vector is heap allocated, standard array is stack allocated. And there is nice methods to it, and it's a very C++ way of using this data structure. Yeah. So uh, you you can probably refer to the code from last week. Sorry. Okay, I think this is just a second. Okay. I hope I'm audible. Yeah. So yeah. So there's a question in the chat. So thing is, the lectures should be shared with you and with a Google Drive link. So hopefully you can access that and then see the code. If not, then I can just quickly discuss that also. Maybe I'll do the reference question and then maybe come back to this again. Yeah. So let's say I define a function which is, let's say, fn integer. Okay. Now what this does is it takes integer pointer type with p. Okay. Now what this does is it takes the pointer p and then just prints it. Okay. Um, yeah. So what I'll do is p. Actually, more to be more specific, the reference to p. I'm audible, right? Can someone confirm?
Yes, sir.
Oh, okay, great. Thank you. Okay, so I'll just end the. Yeah. So there's another question about synchronization. So synchronization usually happens when you have a program doing like two things, maybe simultaneously or concurrently. So usually that happens in concepts like when you have threads in a program where you uh, so let's say a thread is doing a certain task and another thread is doing some other task, but you ensure that in your program your threads at a certain point like they meet when they come to a certain point, both of them have completed their task. So that's called a synchronization. So essentially it is something which comes under the umbrella of parallel programming. So there are three so there are certain so I'll if I may, I'll say there are three major ways people deal with three ways people do parallel programming. So one is with threads, which CPUs have. The other is with processes. So things like MPI programming does that. So your processes also you can synchronize. You can synchronize threads. Third is so these two are from okay. So these two are majorly done in CPUs. So your normal computers which have CPUs. The third kind is in CUDA programming through let's say NVIDIA GPUs. CUDA specific to NVIDIA. You can have HIP HIP for AMD GPUs. You can also have SYCL for Intel GPUs. But there also the same sort of similar idea exists where for a given GPU, so like let's say here we have a single a given CPU might have, let's say, 8 cores, and each of the core has taken different work to do. So that work itself, now you can do it through threads or tasks. Okay. Now, if you do it through threads, then you can have, let's say, 8 threads working in parallel and then synchronize them, or you have 8 tasks for like for MPI processes and then synchronize them. Similarly, on GPUs, we have like thousands of cores. So you can initially just launch thousands of threads, and then after a certain time, they'll get synchronized. So essentially, that's the idea. I do not think parallel programming will be covered in this course, so I may not be able to teach that. But it's definitely an interesting topic, and I definitely encourage to learn that also. So it's a very nice way of taking advantage of the computing power of any architecture, be it CPUs or GPUs or any other evolving architectures, right? Um, yeah. Okay, maybe let's go back to the question. Give me a second. So, so pointers and references, right? So what I did here is defined a function which takes a pointer, okay, and then just prints it. Okay, I need to have a main, so I have to call this function chat monitor. Yeah. So I'll have an integer, let's say defined as n, and I gave some name 5. Okay. Now what I'm doing here is passing uh, this to the function fn. Okay, but it requires the pointer. I can give the address of n, pass it, and then it should take the value and then print it. So this is one way of uh, passing values. Okay. So what people do is instead of just passing this single variable, I can have like, let's say, a vector. This is more common. I'm giving you this example. So instead of just this, I'll maybe define this as size. Okay. And standard vector integers defined with size. I define my size to be 5. Uh, define the vector A with this size, and instead of passing this, I'll pass something called the pointer of A. Okay. Now, the nice thing about again using these C++ functions is there is an inbuilt data type, inbuilt sorry function which already knows what we want to access. So let's say data. So what data does is it gives you the raw pointer to A. Again, remember, A is a vector, so it has a collection of it's like a collection of data. It's heap allocated, but there will be a starting point. So to access that starting point, I can just do dot data function, which will access that member function data for A and give me the pointer. So this is one because it's integer data type. This is all good. So let's see if it files. Then I have reference and dot. Yeah. So again, it gave a warning. So as I said, depending on your compiler, some stuff are it will allow and maybe throw warning. So this is one example. So it's a non-void function which doesn't have return data type. So yeah, that's okay. But this is the let's just say it's a warning, but it's a valid code actually. So what I'm doing is I'm passing the I'm passing the pointer to A here, and I'm printing the first value. So by construction here, because it was all the 5 values, its size is 5, right? So all the values are set to 0. Printing the first value will give me 0. So Hence, it just prints pointer p is 0. Okay. Or maybe just write value of p. The other way I can do is I can do p plus, let's say I want to access the next value, and then it dereference it. Okay. It accesses the first value. Sorry, this should be p plus 1 to make it more clear. Maybe write a loop to actually see what's happening. I less than 5. 5 plus 1. Okay. Put values I I. That should be okay. So it prints the first value is 0, second value is 1. So what I did here is I passed the pointer of A, and after I define all the values and everything, I'm accessing them first value. If I access the first value B, like I'm dereferencing it. So the first value is 0, then the second value is 1. I can just do access each of them like this, or I can actually do like a commit all this, write a loop. You can also do that. So integer I is 0, then I less than, let's say, 5, 5 plus plus, and then standard cout where the value of dereferenced p plus I will be what? So like that, I just write in a loop. So it should be p plus I. Yeah, yeah, that should be okay. So it takes into takes the first pointer, then in a loop it prints out each ith value. So first I 0, 0th value, it dereferences. Dereference, think of it like accessing. So here what essentially is happening is p is the pointer. Okay. So what shift should I take a look at? So first pointer is p, but I'll look at the 0th element. Plus I will like tell me it's the 0th element or the first element, like plus 1, plus 0, plus n minus 1, so on. So those, and then a star operator essentially says what value it stores. It's like a dereference. That's essentially what dereference is. So I'm printing that here. Okay. This is a second way I can do this, where I'll do a overloaded function. Okay. Where it will take, so I'm, what I mean by overload again, so it's the same function but takes different data types. So what it does is I'll just explicitly pass star vector integer, okay, but with a reference for a. Okay. Now what this ampersand here means is my data type is standard vector of integer, but I'm not actually passing only a, I'm passing a reference for a. So I'll call it actually not a but b to um, make my point more clear. What I mean by so the main difference between reference and pointers, they are essentially used quite interchangeably, and the idea behind both of them is the same. So to access data which is not in this scope, right? So let's say I have defined a, right? But to have access in some different function, I can either pass by pointer or by reference. But there's a slight difference also. They both might look the same, but there's a slight difference. So, I'll define 5, 5 plus plus, and then just print standard cout value of if or no, let's go call B. Then B I can just access by, this is also sort of a dereference. The bracket operator also sort of does the same thing. It's just a different way of writing, but it's also dereferenced. I mean, in for arrays it is dereferenced. For standard vectors and such, it's like accessing the value with a operator like bracket operator. Okay. But to access this guy, I'll not do this, but do this. I just pass B. A. No. Let's see how this program runs. Oh, okay. Uh, okay. So the here we see that what I did is I defined my function A, right? And then pass it either the raw pointer, which is the access by dot data, or pass the vector itself, right? So in the first case, when I pass, I did I accessed through a dereference. I access the pointer through a dereference. In the second case, when I'm passing A, I'm passing by reference and accessing B and so on, right? Now here's the main difference. What happens is when you pass a pointer, you're passing a pointer A dot data. Let's say I'll say teacher pointer Q equals to A dot data. And instead of A dot data directly passing, I'll pass Q. Now Q gets created. Okay, I have A dot data, which is the pointer of A. I'll store it in Q. I can define it as some variable Q and store it. Now when I pass Q, here it gets copied to a variable P, and then I access P, which stores the same value as Q, which is the pointer to A. But when I pass by reference A, this variable P actually doesn't exist. It's what the program sees is I'll think of A, I think of B in this function as A itself. So that is the main difference between reference and pointers. So when you pass pointers like this, it actually gets copied. So there's like a semantics like move and copy also. So sort of the same, sort of going in that same direction, which again, those concepts will be covered later in the lectures. But the idea is that your variable gets copied here. So you have a variable Q, which gets copied to P, and P is something which I'm accessing and then doing all the stuff. So here P in a way is a local variable with a local scope. But what happens with references is your uh, A vector actually doesn't it's the same A vector that gets used up here. There is essentially no B. Okay. So, but again, both do the same task. Like for most cases, you do the same task actually. You use the pointer to the variable or heap allocated array or vector or something, and then work with the data or pass it by reference and then work with it. So the idea is similar and same. So yeah, but I hope the difference gets clear. Here I am passing the pointer to A. Here I'm passing the A itself. But do remember not to forget this ampersand, because if I don't uh, put ampersand, what happens is here when I pass A gets copied to B, okay, and then B gets worked with, and B is just a local variable. It's like let's say, okay, maybe I can show the example. Here you might think that since it's printing B is printing all the values same, is the same A, right? Here it's not actually. So what happens here is I am creating, because of not putting the ampersand, I am creating a new B. Okay, I am accessing those values. Creating the new B here automatically copies all the values of A to B also. Okay, that's that is well and good. So hence when I'm printing B, I'm printing all these uh, values which were there in A. But let's say I'll change values of B. Okay, so let's say B I equals to not I, but let's say 2 times I. Okay, and then print these values. Now, this is fine because I changed the values, I printed them. But what happens when I print the values of A? So A still has those values as 0, 1, 2, 3, 4, 5. Okay. Because here A got copied to B and B was changed and then we printed the values. So that is all good. But that information of change to B doesn't affect A because it was a copy of it. But if I change it to have an ampersand, where I'm saying that my A is the same as B, and if I'm changing B, my A should also change. So that's where, yeah, like remember this output where I had changed B with but no change A. And now I have changed B, also changed A. Okay. So what happened here is when I passed A by reference, it's the same A that got passed. So the same A got changed here, printed, and when again after this function ends, I print A, it has the changed values. Okay. So I hope this clears the difference between pass. So it's like a copy and move semantics sort of, but essentially the idea is that the when you pass just like this, right? Just with a variable, it gets a copy and your original variable doesn't change. And when you pass by reference, the original variable also changes. Okay. There was a question, sorry. Yeah, so there's yeah, the timing is between 6 to 8, yes. So I guess we'll end, yeah. There is a question of, we can have begin inbuilt function. I do not understand the question. Uh, oh, okay. I see. Yes, you can use the begin inbuilt function also. Yes. That's correct. But there is a difference. So while dot data is a pointer, begin is an iterator. For vectors, standard vectors, both are essentially the same thing, but they're idea-wise, they're a little different. For vector, they are the same thing. So because why they're same? Because for a vector, your data are contiguous. Like when I say contiguous, it's like single linear. So you have a starting point, all your vectors are one by one, one by one, one by one. So pointer will, when you start with a first value and then go on, like change your when you access each data with a specific stride, right? Specific 4 byte and then next 4 byte. So your pointer knows how to access those each value. Okay. So pointer is helpful in that, and that's the job of a pointer. But when I say a iterator, essentially in C++, all these data structures like vectors, arrays, and such, even maps and more complicated lists, yeah, like sets and everything. So let's say take for example set. Set, the idea is that you have a collection actually. Okay. Your values need not be actually contiguously stored, but your uh, set, like let's say standard set or something, it will take care of having a collection. You do not need to worry about how it stores the data in actual memory. So for cases like that, iterator is helpful because if you want to like access each elements, right? So then you use an iterator which will access all the elements in that collection. Now that collection itself need not be what do you call it? Contiguous in data, right? So yeah, that's the main difference. So you can use
Sir,
the inbuilt function begin in vector also because iterator and the pointer are essentially doing the same thing. But in more complicated data structures, they um, need not be the same. So like say standard map or list like sets, union, where you use union and such, those kind of data structures, uh, pointer doesn't exactly make sense. So we use iterators.
sir,
I hope that answers the question. Yeah. Okay. Great. Um, so I hope you enjoyed today's lecture and this live session today. There were some good questions, and hopefully, I would say just practice these concepts. And if you have questions, do post it in the forum, and we'll try to answer those questions also. Yeah, let's end the class and then see you guys next week. Yeah, happy coding. Yeah, you're welcome.